Hello students, I am Assistant Professor at LJ Institute of Engineering and Technology. Today, in System of Linear Equations and Matrices, I will teach you new topic, that is diagonalization of matrix. So let's start. Let A be a square matrix of order n. The matrix A is said to be diagonalizable if there exists a non-singular means a matrix which is an invertible matrix P such that P inverse AP equals to D, where D is a diagonal matrix. The matrix P is known as a model matrix, and n cross n matrix is diagonalizable if and only if it has n linearly independent eigenvectors. Now, what is the meaning of n linearly independent eigenvectors? If we cannot write down any vector as a linear combination of other vectors, then we can say that the given vectors are linearly independent eigenvectors. So this is the condition for a square matrix to be diagonalizable. Now we will see working rule for diagonalization of square matrix A. First one is find the eigenvalues of the square matrix A. Second one is find the eigenvectors corresponding to each eigenvalue. Third one is find the model matrix P by writing the eigenvectors as its column vectors. And the fourth one is find the diagonal matrix D, that is equals to P inverse AP. The diagonal matrix D has eigenvalues as its diagonal elements. So these are the working rules for diagonalization of a square matrix A. Now we will see one example related to this topic. Example number 1 is find a matrix P that diagonalizes A and determine P inverse AP, where matrix A, that is equals to 2 0 minus 2 0 3 0 0 0 3. Here A is the given matrix, that is this one. Here the given matrix is in upper triangular form. So its eigenvalues will be the elements of principal diagonal. You can see that below the principal diagonal elements we have 0 everywhere. So we can say that this matrix is in upper triangular form. So its eigenvalue will be the elements of principal diagonal elements. Hence, eigenvalues of given matrix A are 2, 3 and 3, which are the elements of principal diagonal elements. Now we will find eigenvectors corresponding to these eigenvalues. First of all, we will find out an eigenvector for lambda equals to 2. So first of all, we will find out this equation, that is A minus lambda I x equals to 0. So to find the matrix A minus lambda I, we will subtract the value of lambda equals to 2 from the principal diagonal elements. So 2 minus 2, that is 0, then after 3 minus 2, that is 1, and then after 3 minus 2, that is 1. So this is the matrix A minus lambda I, and this capital X is a column vector which is made by the variables X, Y, Z, and that is equals to 0 matrix, 0, 0, 0. Now from this first row we have equation 0x plus 0y minus 2z equals to 0. So indirectly we have minus 2z equals to 0. Now from second row we have 0x plus 1y plus 0z equals to 0. So we have the value of y that is equals to 0. Now from the third row we have 0x plus 0y plus 1z equals to 0. So we have z equals to 0. So from these equations we have value of y equals to 0 and value of z equals to 0. So what about x? Here x is a free variable. So suppose x equals to t1, where t1 belongs to r. Now capital X equals to x, y, z. Value of x is t1, value of y is 0, value of z is 0. Now taking t1 common, so we have column matrix 1, 0, 0, and this is equals to t1, and now say 1, 0, 0, that is capital X1, where capital X1 is an eigenvector corresponding to lambda equals to 2. Now we will find out an eigenvector for lambda equals to 3. So first of all we will find out the matrix A minus lambda I for lambda equals to 3. So to find out the matrix A minus lambda I for lambda equals to 3, we will subtract 3 from the principal diagonal elements. So we have this matrix A minus lambda I. 2 minus 3 is minus 1, then after 3 minus 3 is 0, and then after 3 minus 3 is 0, and capital X is x, y, z, and that is equals to 0 matrix. Now we have to find out the equation from this system. So first equation will be minus 1x plus 0y minus 2z equals to 0. Here you can see that row number 2 and row number 3 both are 0, and leading one is present in column number 1. So x is a leading variable, whereas y and z are free variables. Now this is the equation number 1, minus x minus 2z equals to 0. So multiplying this equation by minus sign, we have x plus 2z equals to 0. Now as discussed earlier, y and z are free variable. So suppose y equals to t2 and z equals to t3, where t2, t3 belongs to r. Now we will find out x from this equation. So we have x equals to minus 2z, and this is equals to minus 2, and the value of z equals to t3. So the value of x is minus 2t3. Now capital X equals to x, y, z, and this is equals to x is minus 2, 3, y is t2, and z is t3. Now we will write down this column matrix as 0, t2, 0, then after plus, minus 2, 3, 0, t3. Now taking t2 common from this column matrix, so we have t2 into column matrix 0, 1, 0, then after plus sign. Now taking t3 common from this column matrix, so we have t3 and the column matrix is minus 2, 0, 1, and this is equals to t2. Now say this column matrix is x2, then after plus t3, now say this column matrix equals to x3, where x2 and x3 are eigenvectors corresponding to lambda equals to 3. Now we will find out model matrix. The model matrix P has eigenvectors as its column vectors. Therefore P equals to 1 0 0. This is an eigenvector for lambda equals to 2. 0 1 0 minus 2 0 1. These are the eigenvectors for lambda equals to 3, and this P is a model matrix. Now we have to find out P inverse. So now here, to find P inverse, we will apply Gauss-Jordan method. So we have P equals to I3P, where I3 is an identity matrix of order 3. Now this is the matrix P, and that is equals to, this is I3, and this P will be as it is. Now we will convert this matrix to an identity matrix. So for that purpose, we will make this element, which is minus 2 to 0, with the help of this 1. So for that purpose, we will apply this operation, that is R1 plus 2R3. So by doing so, row number 1 will be modified, and row number 2 and row number 3 will be as it is. And row number 1 will be 1 0 0 1 0 2, and row number 2 and row number 3 will be as it is. Now in the left hand side we have an identity matrix. So I3, that is equals to, this matrix will become P inverse, and this P will be as it is. So we have P inverse, that is equals to this matrix, that is 1 0 2 0 1 0 0 0 1. Now we know that diagonal matrix D, that is equals to P inverse AP. Now we have P inverse A and P. Now we will find out the multiplication of all these three matrices. So this is equals to, this matrix is P inverse, this matrix is A, and this matrix is P. Now we will find out the multiplication of all these three matrices to evaluate the matrix D, which is the diagonal matrix, and that is equals to 2 0 0 0 3 0 0 0 3, and these values are the eigenvalue of given matrix. Hence the diagonal matrix D has eigenvalues as its diagonal elements. So in today's lecture we have seen the process how to find out the diagonalization of a given matrix A, and we have seen one example related to this topic. Thank you for watching this video. I will see you in the next lecture.